Hi there! This video will summarize the basic properties of real numbers. These properties of real numbers will help us later on understand the mathematical concepts better, especially when we are going to reach to algebra or the fundamental algebra. We can actually include here one of the properties we already talked about in the previous videos, which the property of closure or closure property. Let me remind you the closure property specifies that if you're going to pick elements of the same set and operate them, closure property will be possible if the result is still part of the same set. Just like what happened to the addition, subtraction, and multiplication of integers. You pick two integers, you add them, you subtract, you multiply both of them, the result will still be an integer. But as for the division of integers, there is no closure property. That is one of the properties of the real numbers. But for this video, we are going to talk about the presence of the other properties of real numbers in each of the situations that I will be showing you. So I'm going to share to you right now practice exercise A for lesson number 5, which is concerned on the properties of real numbers. So we have here 9 sets of situations, or to specify, 9 different equations because we have equality signs. And each of these equations here covers a specific type of property of real number. Let's look at number 1. Number 1, we have negative 11 plus 11, which is equal to 0. Take note that the situations on your left-hand side was neutralized to become 0. This number or this item contains the inverse property. We use the red color. The inverse property of addition. Not just any inverse property, but inverse property of addition. Why? Because here we have negative 11 and a positive 11. The We have the presence of opposites, and when we add opposites, the result is the identity element of the addition, which is 0. Right? It is now number 1 covers the inverse property of addition because again there is a presence there's a presence of opposites on one side of the equation. Number 2, we have here negative 3 plus 8 is equal to 8 plus negative 3. We are now concerned with just simply rearrangement of the addends. But if we're going to add any of the sides, let's say negative 3 plus 8, this will result, okay, negative 3 plus 8, this will result, I'm going to write it here, to a positive 5. Use a clear line. This will result to negative 5. But if we're also going to, sorry, that's positive 5. Positive 5. And if we're going to take the right hand side here, 8 plus negative 3, the result is also 5. That's why they are still considered to be an equation. So if we're going to talk about just simply rearrangements of addends, the property being covered here is the commutative property. But specifically, since we talked about addends, or the operation here is addition, we have the commutative property of addition. Just to clarify, we already talked about the presence of commutative property or commutativity for addition and multiplication only. There is no commutative property for subtraction nor division. Number 3, we have here the value of negative square root of 3 plus 0. Do not estimate the value here of the irrational number. We are just simply talking about the presence of any properties, specific property. So we found out here that the negative square root of 3 is added to 0. The result is still the value of the negative square root of 3. In short, we retained the identity of negative square root of 3. So the property for number 3 is simply the identity property. And since we are still on addition, we have identity property of addition. The identity property of addition is simply with the presence of 0, because any number added to 0 is the number itself. Number 4. Number 4 talks about the sum of 19 plus 20 to be added to 21 on your left hand side, and your right hand side, 19 will be added to the sum of 20 and 21. The addends here are now grouped differently. But if we're going to take the values of this, okay, so 19 plus 20, that's 29 before you add 21. So you get 50. Sorry, that's not 29. That's 39 plus 21, you get 60. On the other side, you have 19 plus the sum of 20 and 21, which is 41, you still get 60. Thus, the equal symbol. So we do not, the values are just the same, and then we just concerned with different groupings or different associations. This number item contains associative property, and since it's still in the under the operation of addition, specifically the associative property of addition. Number 5. In number 5, you can notice here that we have the uh, factors 4/5 and negative 5/4. You may be tempted to answer, that's the inverse property of multiplication, because we find here a multiplicative inverse, because 4/5 is the multiplicative inverse of negative 5/4. Take note that if we talk about multiplicative inverse, it's just simply the reciprocal, no changes in sign. Therefore, here we have this doesn't have inverse property of multiplication. Even if we're going to erase this one, let's say we are erasing this one on the other side, okay, we may answer here multiplicative inverse of or inverse property of multiplication. Right, going back to the given, this is not on multiplicative inverse or the inverse property of multiplication. Rather, look at the situations on your left hand side and on the right hand side. We just simply rearranging the factors. So rearranging is is covered by the commutative property. And since we are using the term factors, or they are under multiplication, you can say commutative property of multiplication. Number 6. Number 6 here, okay. Actually, in the left hand side, we have your negative 3 and 1 grouped first before the product is multiplied to 15. On the other side, no more groupings. You may say associative property of multiplication, because you might be tempted with the groupings here. But take note that in the other side, there's no other groupings. If we have placed here 1 times 15 and we group it, let's say if we have placed here 15 and then 1, you could actually say associativity or associative property of multiplication. But since there is none, you can simply take the presence of 1 here, as it did not change the value of the whole. Right? If we multiply it by 1, it did not change the value of the whole. So number 1 there is actually the identity property of multiplication. That's the identity property of multiplication, because the presence of 1 as a factor did not change the value of the left hand side. Number 7. Number 7, 8, and 9 collect as a group is purposely included in this practice exercise, because it as I mentioned earlier, properties of real numbers will be very important in understanding fundamental algebra. So we already include here variables. But anyway, we will just look at the properties, specific properties specified in each situation, not the values. No need to solve first. So as for number 7, we see that x and y here is the same as writing y and x. As a spoiler alert, if we simply write variables side by side, automatically the operation is multiplication. So in short, here it that we have here a imaginary process of a multiplication for both sides, and we observe that there are a rearrangement of factors. So this is concerned with rearrangements. This is under the commutative property. Property of what? Of multiplication. Number 8, okay? This item needs analysis, further analysis, because in the other side you have x plus 7, and here you have here the numbers or the integers 9, -9, and 16, which when computed or operated will result to 7. So they are just the same with x plus 7, and the other side will be x plus 7. But here it's not the 7, it's 7 will be the result when we are going to add this two. So what do you think is the property present here? Okay, for the answer for number 8, 16 can actually be rewritten as, I'm going to write the right hand side, x plus -9 plus 9 plus 7, because 16 is 9 plus 7. So by doing this, we have here this pairing here that will actually be resulting to 0 and leaving x plus 7 similar to the left hand side, the original left hand side. So what is now this, uh, what property is being covered by these two numbers here? They are again opposites, similar to number 1. Opposites will result to 0. Here, they will result to 0 and leave x plus 7. In short, this number contains the inverse property of addition. So there might be times wherein you need to analyze the given properly. Number 9 is very easy uh, to observe. Take note that what happened from the left hand side to the right hand side is simply you multiplied here 3 to all the items inside. So 3 times x, you have 3x. 3 times y, you have 3y. 3 times 2, we have 6. And you copy the operations plus and minus. So in number 9, we simply have this distributive property. These are the answers for numbers 1 to 9 of the practice exercise A of lesson number 5, which is concerned on the properties of real numbers. These are just basic properties of real numbers. We may add here again the closure property if you want, and you might research on other properties. Okay, never as long you may do that. Just don't forget these basic properties, which are essential in understanding fundamental algebra soon. Use this video as your review for more properties of real numbers and understand why real numbers behave in such a way. Thank you for viewing. Goodbye.